Okay, in lesson 4.5, or actually on this particular slideshow, we're going to talk about the general multiplication rule and tree diagrams. Now, I'm just going to really quick go through this because I want to get to a certain point. If two events are resulting from the same chance process, notice they did the probability of A plus the probability of B minus the intersection. Okay? Now, one of the things we're going to talk about is the probability of A and B. Notice this is the probability of A times the probability of B given that A has happened. All right, so that's what we're going to talk about right now. In this case, notice, again, the given part is on the denominator, and then the intersection of B and A is on top. All right? So they're saying if you multiply both sides by the probability of A, then what happens is you're left with this, and then you're left with the probability of A times the probability of B given A. Okay? Now, when you do a tree diagram, notice it's 60% that you hit the snooze button and 40% that he doesn't hit the snooze button, or that Shannon doesn't hit the snooze button. Remember what you have to do is you have to multiply, so 0.6 times 0.7 would be 0.42, this would be 0.18, this would be 0.36, and this one would be 0.4. So if you were to add up all these two would add up to 60, these two would add up to 40, and if you add it all together, it adds up to 1. So remember, this entire thing is called your sample space, and these are the probabilities of each outcome. Okay? Now, as we move on, the tree diagram shows the sample space of a chance process involving multiple stages. All right, so now what we're going to do is we're going to take a look at the probability that that Shannon hits the snooze and is late. So what we want to do is, just like the formula said, we want to hit probability that the person hits the snooze times the probability that Shannon is late, given that Shannon hits the snooze button. I know it's a lot to take in, but just bear with me. So as we move on, you're going to see here in a visual in a second what I'm talking about. Okay? So in this visual right here, notice the probability that someone is late. Well, the probability that someone is late happens 2 times. So what you end up having to do is you multiply 0.6 times 0.3 and 0.4 times 0.1. But then in order to do the probability that someone is late, you have to add both of those two. All right? So that adds up to 0.22. All right? Now, so some interesting conditional probability questions involving going in reverse on a tree diagram. For instance, suppose that Shannon is late for a class on a randomly chosen school day. What is the probability that she hits the snooze button that morning? So the probability that someone is late, so we can use the information from the tree diagram, okay? So notice, so the probability that the person is late, hits the snooze, and is late. So because it's an and statement, okay, hits the snooze button given that she was late. So we're working backwards, actually. So given that she's late. Remember, your given goes on the denominator. The intersection of snooze button and late, the intersection goes on top. So that means hits the snooze button and late, that's this one right here, which is 0.18. All right? Over the probability that they're late. So this one was 0.04. When you add those two together, that's your denominator, because that's the probability of someone being late. Okay, I know that's a lot to take in. This is an example of, you could actually practice on this question, okay? And with the review that I'm about to give you, you'll see how this plays out.